I'm Anil Kumar. In this video, I'm going to review polar coordinates. We'll consider what a polar coordinate system is, how to plot points using polar coordinates, and how to find several polar coordinates for a given coordinate. We'll convert from polar to rectangular coordinates and from rectangular to polar coordinates. We'll transform equations from polar to rectangular and from rectangular to polar form, and we'll also derive a formula to find distance between 2 points when polar coordinates are given to us. Now let me begin with what polar coordinate system is. As you know, it includes a pole here right in the, you can say, the origin, and a polar axis which normally corresponds to our positive x-axis. So with just these two things, we define our polar coordinate, right? So this point here is called the pole, and this particular thing is called polar axis, which corresponds to x-axis positive in our coordinate system. Now, how to represent anything in polar coordinate is with the help of two parameters, and these two parameters are called r and theta. So any point P could be represented as r and theta. So these are the two coordinates. So to represent these points, what do we really do is at a given angle theta, we actually, keeping this as our initial arm, the terminal arm is along the angle theta, and once we have the terminal arm, then the distance r is marked on this. Let's say r is 2, for example, then it'll be 2 units, and this segment will represent the point. For example, in this case, if I am marking this as 2, and let's say this angle is 40 degrees, for example, in that case, this will be known as 240 degrees, correct? Now, we'll also consider a few names which we give to r and theta. We'll be referring r as a radial coordinate, or at times as radius. As far as theta is concerned, we'll call this as angular coordinate, or we can say polar angle, right? Or we can say azimuth. Sometimes we also refer this as an amplitude. This size of angle, amplitude, right? So that is how we refer to r and theta, and I hope it's very clear that we have pole, which normally written as O, right? Polar axis is corresponding to the x-axis in coordinate system. The angle theta is considered positive when counterclockwise, as shown here, right? So theta is positive when counterclockwise. Okay, so with that, let's move on and get some examples going. Now, first example here is, we'll plot points using polar coordinate system. The question here is, graph these points on the same polar coordinate, right? So that's what we'll do. So let's make a polar coordinate. That means one origin here at O, and this is our polar axis, correct? That's it. There is no y-axis. Let's be very clear about it, right? So in polar coordinate system, we are always talking about a pole, and we'll always write O there for the pole, and the arrow here is the polar axis, correct? Now let's see how to draw or how to represent all these points in this two-dimensional paper. You should remember that polar coordinate system is for 2D figures, two-dimensional figures, right? So the first one here is 120 degrees. So I'll make actually rough sketches, but that will give you a fairly good idea of what we're trying to do here. Now 120 degrees is, let me approximately draw some points so that we understand. 120 degrees is dividing this in 3 equal parts, right? So you get kind of here. So what I'm trying to show you here is that this angle is 120 degrees, right? So that is 120 degrees. So first thing is, you should define your terminal arm. So move it counterclockwise for the given angle. And the second step is, we have to mark 2 units. So let's say this is unit 1 and that is unit 2. So this point here will represent point A for us, correct? So I'll write this as A, which is 220, correct? Now let's get to B, which is minus 345 degrees. So for 45 degrees, we'll first draw 45 degrees, so which is half of 90, say let's say like this, right? So this becomes 45 degrees, correct? So this angle here is 45 degrees, okay. Since we have to do minus 3, then our value, instead of marking it on this side, we will do it on the other side, right? So that is what it is, right? So now on this side we have minus 3. So 1 unit, 2 unit, and 3 units. So this distance from here to here will represent point B for us. Is that clear? Now let's look into another point, which is point C for us. Now this time we have angle as polar angle as minus 30 degrees. So we'll make 30 degrees on this side. So right. So this is kind of like this. If I go with my 120, 90 plus 30, correct? So 30 degrees is this side. This is my minus 30 degrees. Clockwise, correct? And in this direction, our value is 4, right? So we'll say 1, 2, 3, and this is 4. So that becomes the point C for us. Is that clear, right? So that becomes the point C for us. Now what we have here is minus 2 and 0 degrees. Now when we say 0 degrees, that means terminal arm coincides with this arm itself. So it is 1 and 2 on this side. Minus means reflected, so it would be on the other end. So that will represent the point D, which is minus 2, 0 degrees. So I hope you understand, whenever our value is minus, it is reflected and it is on the other side of the arrow. Now we have 2 minus pi by 4, right? So we have pi by 4 here, and when we say minus pi by 4, we'll actually take it on this side. Let me just sketch minus pi by 4 now in a different ink. So we'll say this is minus pi by 4 for us, right? And 2 units. So we say 1 and 1, 2. So that represents point E, where this angle is minus pi by 4, right? Okay, so that is pi by 4 minus. I wanted to write 45 degrees anyway. So that becomes minus pi by 4. So I hope it is very clear that whenever you are representing these points, it is represented as a segment with center at the pole O, right? Terminating arm makes the angle given to us. Minus value of R represents a reflection, right? And minus angle means you have to move clockwise, correct? So with all this, let's move on to the next exercise, where we'll like to find several polar coordinates. Now it is very important to understand that a polar coordinate is not unique in itself, right? So it could be represented in many different ways, right? Now we need to plot point P, 330, and find other polar coordinates r theta of this point, for which r is given different conditions, right? So now we'll do this. Now in this particular exercise, r is given different conditions. Now this is a very important exercise. We need to find several polar coordinates for any given coordinate. So the question here is, plot the point 330 and find other polar coordinates r theta for this point for which three different conditions are given to us. R is greater than 0 and R is between 360 degrees and 720 degrees. R is greater than 0, R is greater than minus 360 degrees and less than 0 degrees. And then we have R is less than 0, but R is between 0 to 360 degrees. Correct? So first exercise, let's just plot the point P. So when I say P is 330 degrees, that means from the origin, we'll draw the polar axis, and on the polar axis, keeping that as the initial arm, we'll make an angle of 30 degrees, right? So this is the angle of 30 degrees for us. At this angle of 30 degrees, we'll draw our terminal arm, and the length of this terminal arm will be taken as 3 units. So let's say this is 1 unit, 2 unit, 3 units. So that becomes the point P. So I'll mark this as my point P, correct? So that becomes point P for us. So first part, very clear how to plot a point. We have already seen. Now the second part here is how to write them with different angles. Since you can go like this, 360 to 720 really means we are looking for an angle which is kind of like this. Do you understand? That is what we're looking for. So everything else remains same, and so we could write this point P now as R value is 3. However, the angle will be 360 degrees plus 30 degrees, right? So it becomes 390 degrees. So what you can do here is that to get the angles, formula could be R, and the theta value is increased by 2 pi multiples, right? So we could have theta equal theta plus 2 pi times n, right? So where n belongs to set of integers. So that is how we could do it, right? So that is how we get the first one. Now the second one here is R is greater than 0 and the angle is less than 0 but greater than minus 360, right? So basically we have to express this as the negative angle. So what you can do now is that you could represent this as, let me sketch it, show you first how. So what we will do, let me take a ink which is, let's do it this, okay, doesn't matter. So minus 360 means we'll go this side now, like this. Do you understand? And then we can come back to this. The same point. I mean, that's the point. So the magnitude, I mean, I should not say magnitude, the length of this segment remains, which is 3, will remain always 3. And the angle, since you went like this, it will be 30 degrees minus 360, right? So this time it is 30 degrees minus 360 degrees. So it is minus 330 degrees. Do you see that? So we get our polar coordinate 3 minus 330 degrees, which is being represented here. Now the last example here is we are saying R should be negative, right? We are saying R should be negative. Now in this case, what should we do? Now if I am taking R as negative, in that case, theta becomes theta plus pi. Do you see that? Well, I should write 360 degrees, right? And then we could do 2 pi n, right? Well, when we are working in degrees, I could write this formula as R, theta plus 360 degrees times n, same thing, correct? But whenever you do minus R, that means you have shifted it to this side. So the angle will be, you had to add pi to it to come back to the same point, correct? So that makes sense, theta plus pi, and then you can do combination of 360 degrees. Is it okay? That is what it means. So when R is less than 0, we'll write our point P as minus of 3, right? So minus of 3 means we are looking at this side. we are looking at this side. Is it okay? So it comes here. But when I add 360 degrees, again I wrote this. Okay, so yeah, so instead of pi, 360 degrees. So when I add, 180 degrees. So when I add 180 degrees, I come back to the same point. You get an idea, correct? So it is theta, which is 30 plus 180. So we'll add 30 plus 180. So when you do that, 3 plus 8 is 11, 210 degrees. So that's what you get. So it'll be 210 degrees. So P minus 3, 210 will give you the same point. Got it? So that is how it can be done. So I hope that is clear. I'd like you to go through this once again so that you understand what we really did here to show that this point is not unique, right? So this point is not uniquely defined. There are so many other ways you can represent the same point as. Perfect? Okay, so the next question here is convert from polar to rectangular coordinates. Find the rectangular coordinates of the points with the following polar coordinates. So now polar coordinates means we are talking about r theta, right? So we have this r theta. Now we have to convert this to xy. So that is the rectangular coordinates for the same thing. Now in this case, we know r is equal to 4 and theta is equal to 60 degrees. Now how do we convert it? So let me make a small sketch and then we will do the needful. So let us say that we have this polar coordinate. Now if I superimpose on this the rectangular coordinate, what do I get? So let me superimpose the rectangular coordinate now, right? So this is the rectangular coordinate. Is it okay? So that becomes the rectangular coordinate. Now when I say 460 degrees, then it really means that I'm looking at a point which is being represented at an angle of 60 degrees and 4 units away. So it is kind of like this, right? So let's say this is your point which we're talking about. Let me call this point as A for the time being. A, right? So the angle here is 60 degrees. And this value is R, correct? To write it in the XY system, the rectangular coordinates, we can take R of cosine theta to get this value, right? So it becomes X value becomes R of cos theta. So X value is 4 cos of 60 degrees. And the Y value will be 4 sine of 60 degrees. Correct? So we get it. You can use the calculator to find the angle, or you can use special triangles. I will be using special triangle since I have such values taken. So if this is 60 degrees, we're talking about 1, 2 and square root 3. So cos of 60 degrees is half, correct? So this value becomes 4 times half, which is 2. And the y value becomes 4 times square root 3 over 2, right? Square root 3 over 2, which is 2 square root 3, correct? And therefore, the point A could be written as 2 square root 3. Perfect. That is how you're going to do it. Now, I'd like you to pause the video, do the next one, which is minus 5 minus 45. Now, first question is, how are you going to represent it? It is a good practice, right? We just learned, we are reviewing all this. Well, so whenever we say minus 45 means we are going to do like this. That is, we are going to look at this line, which is minus 45. Perfect. On this, we'll plot 5. And since it is minus 5, we're going to reflect it on this side. So the point here is, let me call this point as B. So this point becomes B for us. Perfect. So we're looking for that point now. Since it is in quadrant 2, we clearly know that the x value is negative and the y value is positive. Is it okay? So that's very clear. Now we are going to use that x value negative, positive value for y, and then get our answer, correct? So here again we have x value which has to be negative. We are in quadrant 4. We'll just write negative. Use the same angle, 45, right? So we have 5, which is the r value, right? R value of 5, and cos of 45 degrees, which gives us minus 5 times 1 over square root 2. As far as y value is concerned, it will be positive. This is positive. 5 sine of 45 degrees, correct? Which gives you the value of 5 over square root 2, correct? And therefore, this could be written as minus 5 over square root 2 and 5 over square root 2. Perfect. So that is how you could do it. So you can take a few more examples to practice, but I hope with this you get an idea how to deal with negative values of r and negative values of theta. The next example here is to convert from rectangular to polar coordinates. So we have two examples. Find the polar coordinates of a point whose rectangular coordinates are given to you. So let me just sketch the rectangular coordinate this time. The value given to us is 1 square root 3, let's say. So this is, let's say 1. Let's say this point. Okay, so 1 square root 3. Now that becomes the point. On the polar coordinate, we are looking for pole at the origin and the polar axis along the positive axis, right? And that becomes our segment, which is to be defined, right? So we're calling this point as, let's say, P. So this is the point P. Now how do I write this in r and theta terms? So one way here is that we can just write, we can find what theta is. These are x and y values, right? So if you think about a triangle here, we know this height here is square root of 3 and this base is 1. So we know tan theta is equal to square root 3, correct? And that gives us theta equals to tan inverse of square root 3, which you know is 60 degrees, correct? You could use your special triangle or your calculator, right? So that is a special triangle which we could use. So this becomes 1, 2 square root 3. The angle here is 60 degrees for a 90 degree. Okay. So we know this. Now we have to find what r is. So you could find r as equal to square root of 1 square plus square root 3 square, correct? Which is square root of 1 plus 3, which is square root of 4, or you can say 2, right? So we get r value, and therefore we can write point P as 260 degrees, right? Now all these calculations can also be done in radians, correct? You can write this in radians. Also, you could write this as P2 radians will be pi over 3. Both are correct. So theta could be in radians or in degrees. Now the next example here is, the point is 3 minus 3. So let's take 3 minus 3 now. So 3 is here, let's say 3 is here, and minus 3 somewhere there, right? So let's say this point is Q for us. Okay, so this point is Q for us, this is minus 3. Now let me draw the segment, okay, representing OQ, right? Okay. So first step is the angle, which we know is negative of the angle. So we can say tan theta is equal to, you could use minus 3 over 3. So you get minus 3 over 3 is minus 1. So we get theta equals to tan inverse of minus 1, which you get minus 45 degrees, or pi by 4, as you wish, right? Negative. So we know the angle theta. Now we need to find r. To find the value of r, we can say r equals to 3 square plus square root 3 square, square root, add them and find the square root, which gives us square root of 9 plus 9, which is 18, which is 9 square root 2. Correct? So that is how you get the value, and you can write this point as q in terms of r, which is 9 square root 2, and the angle minus 45 degrees. Correct? So that is how you could always change. So what we learned here, basically two formulas to convert, which is r is equals to square root of x square plus y square, and theta as equals to tan inverse of y over x. Correct? Now it is also very important to understand that we have to do some adjustments for the angle theta. So the examples which I took were straightforward. Now we have two more questions based on how to convert rectangular to polar coordinates, and I hope that will give you more insight to what we just learned. So the question again is, find the polar coordinates of a point whose rectangular coordinates are given to us. So let's draw the rectangular plane, plot the points, and do the needful. So the first point given to us is minus square root 3, 1. That means it is kind of here. So that becomes the point for us. Minus square root 3, 1. Now that is on the polar coordinate. If I superimpose that on you, so, okay, that is how it should be. So what we learn here is the value of r can be easily found by doing square root of x square plus y squares. That means minus 3 square root square plus 1 square, which is square root of 3 plus 1, which is 4 square root, which is 2. So we know the magnitude r is 2 for us. Now as far as the angle theta is concerned, how do we find angle theta? So we could do tan inverse of y over x, which is 1 over minus square root 3, right? Now if you do this on calculator, right, what do you get? Now I am going to use special triangles here, so I'll use special triangles. Okay, so square root 3, I've purposely taken these values so that I don't really have to use calculator. So when we say this, we are talking about this side. Is it okay? So the angle which I'm going to get is this angle. Tan is 1 over square root 3. So 30 degrees with a negative sign. So I'm going to get this minus 30 degrees. Is it okay? So that gives me answer of minus 30 degrees. Clearly, the angle is not minus 30 degrees, right? So to get my angle theta, what should I do? So I do theta as minus 30 degrees plus 180 degrees. Perfect. I have to be in quadrant 2. And that gives me a value of 150 degrees, I'm sorry. Right? So you get 150 degrees as your answer. So what you learn here is that the angle theta is equal to pi plus tan inverse of y over x. Is it okay? If you are in quadrant 2, right? If you are in quadrant 2, correct? Now the second example here is minus 2 minus 2. Minus 2 minus 2 means you are in quadrant 3, right? So this example is for quadrant 3. Okay, let me first write on the answer in r theta without jumping. So r is 2 for us and theta is 150 degrees. So that is how you convert this. Now, so that is 150 degrees and this is 2 for us. Now in quadrant 3, we have taken this minus 2 minus 2. So let me sketch this here. Let's say this is say minus 2 minus 2 somewhere here. Okay, let's say that's the point. So that is minus 2, this is minus 2. Now in this particular case, finding r is not difficult, as you saw, simple as that. R is square root of x square plus y square. I've just written the formula. In this case, minus 2 whole square plus 2 whole square, which is square root of 4 plus 4, which is 8, and 8 could be written as 2 square root 2, correct? 4 times 2, 2 square root 2. So we get this r as 2 square root 2. Now theta is equals to, I should not write theta, we are trying to find the angle, alpha first, some other angle, right? Which, when you do minus minus, you do tan inverse of minus 2 minus 2. Writing minus 2 makes it plus 1, correct? So you get 45 degrees, not the angle which is required, correct? So what you get here is this angle, 45 degrees. So to get the correct angle, we actually add 180 degrees to it so that we ensure that we are in quadrant 3. Only then the answer is correct. You get my point, right? So what we get here is 5, 4 plus 8 is 12, 2, and then 225 degrees. And therefore, the answer for this becomes r value is 2 square root 2, and the theta is 225. Now, as you know, in polar coordinates, we could represent it in many different ways. You could use 45 degrees with minus r value. You could do that. So again, what we learned here is that theta is equals to pi plus tan inverse of y over x if we are in quadrant 3, right? So whenever you are in quadrant 2 or 3, theta value actually is pi plus the angle which you find, and r value is always x square plus y square square root, correct? So that basically becomes your conversion formula. Is that clear to you? Now, if it is not quadrant 3 and 2, then we do not add pi, correct? So let's move on. I hope this concept is absolutely clear. Now the question here is, relate rectangular to polar coordinates, complete the following table. This is an exercise for you. So what we have here is some rectangular coordinates given to us, and we have to relate them to the polar coordinates, correct? So 5, 0. Well, so these are interesting examples when I'm saying 5, 0. So, okay, so what I'll do here is that I will just draw coordinate system we are representing by green color most of the time, and polar system by this blue color. Okay, so in this case we are talking about point 5, 0. 5, 0 means x value is 5 and y value is 0. That becomes the point, right? So if that is the point, that means the angle is 0 for us, but r value is 5, correct? The length is 5, and therefore the polar coordinate will be in this case same, right? 0 degrees. Is it okay? That is how the polar coordinate will be. Now if I am saying 3 pi by 2, so if I say 3 pi by 2, 3 pi by 2 is this angle, correct? Kind of like this. Now that becomes 3 pi by 2. So we are now looking into a corresponding point in this direction, kind of somewhere here, right? So we know the x value is 0 here along negative y-axis, and negative 3 becomes the y value. So these two are equivalent. So you see how you convert it. The second point C here is minus 2, 0. That means x value is minus 2. So minus 2, 0 maybe y value 0. So we are on the x-axis negative side. So that makes an angle of how much? 180 degrees. Do you see that? And r value is a square plus b square square root, which will be 2. So this could be written as 2 and the angle as 180 degrees. Of course, you could write 0 and you could write minus 2 and 0 degrees also. The D part is 1 pi by 2. So pi by 2 is, if I have to represent pi by 2 on this, that means we're talking about this side, correct? And 1 unit, let's say this is 1 unit, so this becomes 1 pi by 2. Now, if that is 1 pi by 2, in the coordinate system, I'm looking for a point somewhere here, x value is 0, correct? X value is 0, so first 0 for x value, and y value is 1. So that is how you get it. So I hope this exercise is well understood. It is sometimes create confusion. You can pause the video, understand how we have linked rectangular coordinates and the polar coordinates, especially when the points are on x-axis or y-axis in rectangular coordinate system, right? The next example here is transform equations from polar to rectangular form. So we have a question here which says transform the equation r equals to 6 sine theta from polar coordinates to rectangular coordinates and identify the graph. So we have the equation r equals to 6 sine theta. You can pause the video, answer the question, and then look into my suggestions. Now there are steps to follow. So whenever you do this, the first step is you should times r both sides. So whenever you are actually transforming equation from polar to coordinate, rectangular coordinate, this is the first step. So what you do here is that you have this equation r equals to 6 sine theta, multiply both sides by r. So you do r times and there do r times. You get an idea, right? So r times r is r square, and here you get 6r sine theta. Now what is r sine theta? It is y, correct? It is r sine theta is y, correct? So we can write this place as just y. Is that okay? Since you know the conversions, when we are talking about, we know r is equals to square root of x square plus y square, and we know x is r of cos theta and y is r of sine theta. Perfect. So that is what it is. So you get r square. R square is square root of x square y square. So I could write this as r square is x square plus y square equals to 6y. Does make sense to you? So I replaced r with x square plus y square. Let me call this as my equation number 1, right? We call this as 2 and this as 3. So we substituted from 1, right? So we substituted from 1, and this place we got from this 3. Perfect. So that is how you get it. Now that actually is the equation of a circle. X square plus y square equals to something else. Now to get the equation, really, we may have to complete the squares. So we'll complete squares now. And get the equation with its center. So we have x square plus y square minus 6y equals to 0. To make it a perfect square, I have to add few terms here. What should I add? So it could be 2 times 3 times y, right? So 3 square I have to add both sides. So I have to add 3 square both sides. Do you see that? So once I add 3 square, I could write this as x square plus, this becomes y minus 3 whole square equals to 3 square, which is 9. Correct? So what is this? So clearly you understand what we have got into. Let me push this page a bit. Right, so I hope you can see it now. So what we have here is a circle. So what we get here is equation of a circle. So we have circle whose equation is x square plus y minus 3 whole square equals to 3 square, which is 9. So with center at 0, 3 and radius as 3, correct? So that is what it really represents. So at times, so these are the standard steps which you need to follow. I hope those steps are clear. And now you should be clear in your mind that how this polar equation could be represented on the Cartesian. Even otherwise, if you sketch it, this is what you're going to get. So if you sketch it, you get on the polar coordinate system at 0, 3, right? So the x value is 0, somewhere here 3. You get a circle whose radius is 3. So you get a circle which is kind of like this. Do you see that? So that is what it represents. So let's move on. Here is a practice test question for you. You need to do conversion of equations. We are given polar form and also coordinate form. So fill in the blanks kind of thing, right? So for r equals to 5, what should be the equation in coordinate form? For y equals to 3, what should be equation in polar form? Y equals to x is what? Here, and r equals to 6 cos theta should be written as what? So that is the question for you. I'd like you to pause the video, answer the question, and then look into my suggestions. The steps to be followed are kind of like this. We know that r is equals to square root of x squared plus y squared. We prefer to write this as r times r, which is r squared equals to x squared plus y squared. As far as x and y values are concerned, x is r times cos theta and y is r times sine theta, right? So that should help you to answer this question. First equation here is r equals to 5. If I times with r on both, I could write this as, I could just square this, right? Or if I just times it with r on both sides, I could write this as equivalent to r square equals to 5 times r, which is 5 times 5. Is it okay? So r square is 5 square. Writing in coordinate system, it gives me x square plus y square equals to 25. Perfect. So that is a circle, as you can see, with radius of 5 units. So that becomes a circle with radius of 5 units. Okay, so let me sketch that here on this side. So the first equation actually represents a circle of 5 units, right? So this radius is 5. Okay. The second equation is y equals to 3. As you know, y equals to 3 is a horizontal line. So let's say this is my line, which is y equals to 3. How do I represent this in the polar form? Well, we know what y is. So it's straightforward, as you can see. Perfect. So we know that y is r sine theta. So I could straight away write this as r sine theta equals to 3. So r sine theta equals to 3 represents a horizontal line, as you are seeing here. Is that clear to you, right? So that is how it is. Now let's look into the next line, which is y equals to x. Now if I draw this line y equals to x, what do I get? Now clearly that means this is 45 degrees. Is it okay? So you could see for yourself that y equals to x is a diagonal line which cuts through the coordinate system in coordinate plane, and it could be written as, you know, theta is 45 degrees, correct? So this could be written as theta equals to 45 degrees. So that equation in polar form really gives you the equation of this kind, correct? Now that is simple to figure out. You can replace y with r sine theta, right? And x with r cos theta. R cancel, right? So you get tan theta equals to 1, which is theta equals to 45 degrees. So I'm leaving those details for you to do. The next one here is r equals to 6 cos theta. We did an example very similar to this. So I'd like you to follow the steps which we did here with r equals to 6 sine theta. So the only change will be r cos theta is going to be x. Then you do completing the squares for x, correct? And you should get your equation. So if you do that part, so the answer should be x minus. I'm just copying from the previous example. y equals to 9, right? So, I mean, this will go here. So, we get a circle which is x minus 3 whole square plus y equals to 9. That should be your answer. The steps involved are same as we did in the previous example. So, this will be a circle for you whose radius is going to be, well, center is 3, 3, 0, right? So center is 3, 0. So it'll be kind of 3, 0 here, and the radius is 3 units. So it'll be a circle which is kind of like this. Okay, so that is what you're going to get here. So I hope with this you understand how to convert equations from polar to coordinate forms and vice versa. So now here we have the exercise which says transform equations from rectangular to polar form. Okay, so we did a part of it in the previous exercise. The question here is transform the equation 4xy equals to 9 from rectangular coordinates to the polar coordinates, correct? So we have 4xy equals to 9, and you know what x is? X is r cos theta and y is r sine theta, correct? So let's replace x and y with that. So we get 4 times r cos theta times r sine theta equals to 9, and that becomes 4 times r square cos theta sine theta equals to 9. And you know what 2 sine theta cos theta is? Is sine 2 theta. So you can apply this trigonometric relation to simplify this. So 4 could be written as 2 times, we'll write this as times 2 here. Rearrange sine theta cos theta equals to 9, and that gives you 2 r square, and that is sine 2 theta equals to 9. So what you see here is an equation which is in terms of r and theta, and so it will be referred to as a polar equation, correct? So we have r square sine 2 theta equals to 9 divided by 2 or 4.5, correct? So that is how you can actually write this equation, or you can leave it as such, it doesn't matter. So both are correct either way. So let me just highlight that as our equation in the polar form, right? So either one of these two. But I hope you understand the concept, which is we have to use these relations to actually get to our result. So at times you need some trigonometric relations to work with to help you. So you may have to brush up that also. Now here is the almost the end for us. I see some more questions coming up. Distance between 2 points in a polar system. So well, the question here is, show that the distance d between the 2 points r1 theta 1 and r2 theta 2 is given like this. Okay, so that should not be difficult. We know our polar system, which is kind of like this. Let's consider the 2 points given to us as r1 theta 1. Let's say this is r1 theta 1, okay, and let us also make another angle for r2 theta 2. So okay, so let this be r2 theta 2. Okay, so what we have here is this length is r1, the angle here is theta 1, and then here we have r2, and this whole angle is theta 2. That means the center angle is theta 2 minus theta 1, correct? That is the central angle. The distance which we are talking about is between these 2 points A and B. So this is the distance we are talking about, right? So that is the distance we are talking about. So what we can do here is, let me write down this point as A, this as B, and that is always O for us. So we can use cosine law. Perfect. So cosine law directly gives us the result, and so we know AB, we can say AB square, right? AB square will then square root later, right? So AB is square of OA plus OB square minus 2 times OA, OB, cos of angle between them, which in this case is theta 2 minus theta 1. Perfect, right? So this distance d square is OA is r1 square plus r2 square minus 2 times r1 r2 cos of theta 2 minus theta 1, correct? Or d is equals to, as given here, r1 square plus r2 square minus 2 times r1 r2 cos of theta 2 minus theta 1, correct? So that is the formula. You can always apply this formula and find distance between any two given points, right? So take some examples. For example, you can say the points P are 5 and 45 degrees and Q is, let's say, 6 and let's say 60 degrees, right? So find the distance between the points P and Q. Let that be an exercise. Okay, so this is the last page. It's kind of a review, true or false questions. We have 5 questions here. Question number 1. Polar coordinate system is a two-dimensional coordinate system, true or false? So I'm leaving answers for you. We'll just read the questions. You mark them true or false. Provide reasons. Question 2. In polar coordinate, r theta, r is called the amplitude and theta is called the azimuth. Question number 3. The value of r and theta can be negative in a polar coordinate r theta. Question number 4. The polar coordinates of a point are unique. Question number 5. R sine theta equals to 3 square represents a circle. So true or false? Okay, here are the answers. First one. Polar coordinate system is a two-dimensional coordinate system. So that is true. A polar coordinate r theta, r is called the amplitude and theta is azimuth. This is wrong, right? This is false. R is not called amplitude, okay? So R is the radial coordinate or radius. So R is radius or radial coordinate. At times we do refer theta as amplitude, okay? So how big or small the angle is. Question number 3. The value of r and theta can be negative in a polar coordinate. Yes, that is true. We saw so many examples. Question 4. The polar coordinate of a point are unique. False. There are so many different ways of writing it, since we can add and subtract multiples of, integral multiples of 2 pi or 360 degrees. R sine theta equals to y square represents a circle. What do you think? Well, r sine theta is what? Y, right? So it is y equals to 3 square is 9, and that is actually a horizontal line, right? Not a circle, right? So this statement is again false, correct? So with this, we come to an end of our exercise on polar coordinate review. So I hope that helps. Feel free to share your comments and remarks. And if you like and subscribe, that'll be great. Thanks for watching. All the best.